let the engine run at a constant engine speed. Constant engine speed on this machine means 1800, maybe 1850 RPM, which is much lower than the Caterpillar usually runs at, which first saves you fuel, reduces the wear on your engine and everything. Why is it important to let the engine run at that constant engine speed? Every engine has its, what you can call it, a sweet spot or so, where it runs most efficient. As I said, on this machine, 1800 RPM. If you would go higher, you lose efficiency. If you go lower, you lose efficiency too. The same thing is on the Caterpillar. That engine has its sweet spot too, so there's a certain engine speed where this machine runs most efficient. The problem you have on the Caterpillar is you only have 3 gears. So you have exactly 3 speeds where this machine runs at its highest efficiency. All the speeds in between, you lose that efficiency. The end result is, when we compare those machines, you see fuel savings on the Liebherr between 8, can be 12, can be 15, 17%. It very much depends on the application. In numbers, this means it can be as much as 1.5, maybe 2 gallons on a machine like this, and larger machines even more gallons per hour. 2 gallons per hour, just as an example, with fuel prices at $3.50 a gallon, over 10,000 hours means $70,000 you have saved by running a hydrostatic machine instead of other machines. Our hydrostatic concept is unique. We have a way to keep the engine speed lower than any other competitor machine, so even when we compare our hydrostatic machine against our competitors' hydrostatic machines, we're still save fuel. The way the Liebherr machine is set up with its hydrostatic drivetrain is, we have the Liebherr diesel engine, and then we have a transmission which is called the splitter gearbox. This transmission has no gears to shift, no clutches, no nothing. It's really just a gearbox to split up the crankshaft that comes out of the engine in 2 output shafts. So what we do is, with the 2 output shafts, we have the left side pump, we have the right side travel pump next to each other and not stacked behind each other as our competitors do. So this has 2 reasons why we do this. First thing is, we can keep the engine speed lower. We talked about 1800 RPM on the smaller dozers. On the larger dozers, it's even lower than that. There it's about 1600 RPM. When you compare this to our competitors, they run theirs at 21, 22, sometimes 2300 RPM. The reason is they don't have the splitter gearbox behind the engine. So they have to have the left, let's say the left side travel pump. Behind the left side travel pump, they have the right side travel pump, and then they even stack attachment pumps on that. So you have a very long stack of pumps which can start flexing and is not nearly as efficient as when you have it side by side and can keep the engine speed lower by that. That's the main difference. The other difference is how we have the controls integrated in the machine. This machine, the 734 here, like any other dozers or crawler loaders, have a power on demand feature, also called boost power. The machine is rated, like the 734 here, at 201 horsepower. This is when you do your standard pushing. However, there's certain situations, like pushing through a turn, where you need even more power. During those situations, the machine will give you up to 15% more horsepower, more torque out of the engine. This happens fully automatically without the operator having to push any buttons, nothing. As soon as the operator starts moving the joystick to either left or right side, the engine controller already gets a signal that says, hey, we get into that situation where we have a higher power demand, get ready for it. So the system is not reactive on loads, it's proactive to the load, which means you get more power pushing through the turn and you have more efficiency, because the engine doesn't get pulled down and then has to recover. It stays up at the engine RPM where it should be.